Figure 2 shows a sketch of part of the curve with the equation y equals 4x cubed plus 9x squared minus 30x minus 8 between the values of x that are minus 0.5 and 2.2. The curve has a turning point at point A. I need to use calculus to show the x-coordinate of A is 1. Well, I know at turning points, the gradient is equal to 0. So if I take my function and differentiate it, so let's take the 4x cubed minus 9x squared minus 30x minus 8 and differentiate it to get the gradient function. So the 4x cubed will differentiate to be 12x squared. The 9x squared will differentiate to be 18x, and the minus 30x will differentiate to be minus 30. The minus 8 on the end there, because it's a constant, will differentiate to be 0. At a turning point, the gradient equals 0, so this equation equals 0. And if I now show that when I substitute 1 into this function, I'll get 0. That means that 1 would have to be a turning point. So when x equals 1, dy by dx is equal to 12 times 1 squared plus 18 times 1 minus 30, which equals 0. Therefore, x equals 1 is a turning point. So that's part A of this question done. We're then told that the curve crosses the x-axis at the point B, which is 2, 0, and the point C, which is minus 1/4, 0. The finite region R, shown shaded in figure 2, is bounded by the curve, the line AB, and the x-axis. Use integration to find the area of the finite region R, giving your answer to 2 decimal places. So it's bounded by the curve up to this point here. Then we've got the straight line AB and the x-axis here. So it's bounded by those lines. And I need to find that area R. First thing to note, area R is below the x-axis. Here's the x-axis here. The region we're finding is below that. Therefore, any calculations with integration will give me a negative answer. The area itself will be positive. Obviously, area has to be positive. But I know that when I do the integration, I'll get a negative answer because it's below the x-axis. So bear that in mind. Second thing to bear in mind is the fact that if I use integration, it tells me the area between the curve and the x-axis. So I do not want to do integration between minus 1/4 and 2, because that's going to tell me all of the area between the curve and the x-axis between those values. It's going to include this region here that I don't want. So I am not going to be integrating between minus 1/4 and 2. I am going to be integrating between minus 1/4 and 1, because that's going to tell me this area here. And then I can add in the extra area of this triangle. So let's do the integration. We're integrating between minus 1/4 and 1 of 4x cubed plus 9x squared minus 30x minus 8 with respect to x. So we'll add 1 to the power and then divide by the new power. Add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. And the 8 will integrate to be 8x. So we will get x to the power 4 minus 3x cubed minus 15x squared minus 8x. Now we're going to substitute 1 into this. Then we're going to substitute minus 1/4 into this. And we'll take them away. This is going to give me my answer, which is going to be minus 20.02. So that's this area here. But obviously we don't want to have a negative area, so we're going to make that positive. We're going to turn that into a 20.02. So that's the red area. Now let's look at this triangle. I can see the base of this triangle is 1, because it's the difference between the x coordinates of 1 and 2. The height of this triangle here, well, that's going to be the y coordinate of point A, whatever that is. I know the x coordinate of point A is 1. I can find the y coordinate by substituting 1 into the original function. So when I do that, I find that the y coordinate is minus 25. So therefore the height of my triangle is 25. So the area of the triangle is equal to half base times height, which is 12.5. If I then add that to the 20.02 for the total area of region R, we get 32.52 to 2 decimal places. And we're done.